Madan from Broadcom.
Yeah.
Hi, Nitin Madan. I'm product line manager at Broadcom Wireless Connectivity Division. I'm responsible for 60 gigahertz products and also some of our Wi-Fi combo products for mobile phones.
Okay, and then we have Joey Friend, our friend. Of
Good
Black and Beach.
Good afternoon. I'm Joey Friend. I'm one of the client directors at Black and Beach, and I basically work with all the carriers and fiber companies on solutions for small cell. Black and Beach provides a full turnkey solution for installations, whether it's small cell or macro. Right now, we're focused on small cell because of the challenges that some of our clients are facing. Our role is basically, we've done several different things. Coming in, we have a lot of newcomers into the telecom space that have never worked with the deployment side of it. So Black and Beach has worked a lot with those newcomers in basically training, whether it's with the jurisdictions on the processes that are required there or the public utilities for their equipment approvals and inspections. And we've also, as a result of small cells and realizing the vast volume along with the accelerated rate of deployment, that we would have to come up with a most cost-efficient deployment plan in order to build out the strategy as our business operators need us to do.
Okay, and then we have Mike Galt from ExteNet. ExteNet does lots of different things, but this is as well.
Absolutely, yeah. So I'm Mike Galt. I'm the VP of Network Design for ExteNet Systems. ExteNet is a distributed network architecture owner-operator, so neutral host, a lot of people refer to us as. We do indoor networks as well as outdoor networks, small cells, DAS networks, any kind of interconnected distributed network system. We don't just refer to it as DAS anymore, obviously, because it's not just one topology, it's several. We have networks all across the country, in some cases even north of the border. So we've been doing small cells in some way, shape, or form now for I think we're going on 11 years, something like that. So we've certainly seen this very rapid, very strong influx of demand recently when it comes to small cell deployments. And I think Joey mentioned it best that as a result of that, there is a significant drive towards what the most cost-effective solution is to deploy, as well as how to prepare both the industry as well as the municipalities for this very rapid and very imminent densification that's taking place.
So let me say, and I'll start this question to the whole panel. In terms of what you see, currently, and what you perceive is the market. We do see this acceleration, and at least in the work that we do, it sort of doesn't it just keeps growing kind of exponentially year on year in terms of what the demand is, because of the capacity demand goes. But first, for the deployments that we see today, about what percentage of them are for coverage, and what percentage are to enhance capacity, whether that's in a specific in a specific area? But which percentage do you see from a capacity standpoint, and which from to improve from coverage? We'll go down the line this way for this one.
Well, from our perspective, I would say that most of what we're seeing is for capacity. There are certain areas where there might be a coverage solution, but I would say the vast majority of everything that that we're looking at are capacity scenarios.
Okay.
And we're seeing those in really all of our markets. We operate in 19 different states, and we cover large tier 1 markets, and everyone talks about the dense urban areas that need small cells and so forth. Certainly a lot of activity going on there. We also operate a lot of tier 2, tier 3 markets in some rural areas, and we're involved in large small cell deployments even in these smaller markets, markets that might have a population of 150, 200,000 people. Of course, we also see them on military bases and, you know,
Right.
high usage areas. But I think what surprised me the most is that really the densification is taking place across all the markets.
So even in some of those more outer markets, there's still, you know, maybe not to the degree, but there's still densification that has to take place.
That's correct. And not to the same
Interesting.
degree, and I think some of the points that were touched on here about needing to get the cost down and the price down, what we hear from the carriers are that the density, the volume of small cell units that will be deployed be directly related to the cost. The lower the overall industry can reduce the cost, the more small cells that are going to be deployed.
Okay, Nitin?
I can second those comments. I think coverage as a problem is largely solved. It's about densification and it's about capacity.
Okay. And you guys agree, or? Yeah, so it's nearly 100%, maybe occasionally just to fix a hole or something like that, but that would be it.
Usually where I've seen our teams have done for coverage is basically we're building capacity for small cells, but we're combining ODAS and IDAS for public venues, for college universities, for their stadiums and so forth and so on,
Right.
along with the small cell deployments.
Okay. You know, let's just touch on the technical challenges, and you know, a couple of good things about macro towers. A, there aren't as many of them. B, you know where they are, and they're pretty easy to find, and they're usually along a fiber run somewhere. But the issue with small cells, you know, they could be anywhere. They could be up on a light pole on the top of a building, on the side of a building, on, you know, something else, you know, on top of a bus station. You know, talk about, the technology challenges from the standpoint of, you know, what capacity needs to be met, and then what the challenges are in terms of deployment, and you know, in gaining, you know, being able to gain connectivity with different options. So we'll start with Nitin on this one.
So the only way we can provide gigabit speeds to, let's say, the next billion people on a mobile platform is densification. That's pretty well understood. But the logistics are underestimated. Each of these small infrastructure nodes will have to be supplied with power and fiber or some high bandwidth backhaul. This is more expensive than what we imagine, in the sense of, if you have to dig up the streets in any developed country, this really costs a lot of money. And the permitting process, going municipality by municipality, community by community, blows up any business case. So what we've tried to do is at Broadcom, make the process of connecting these small cells to a fiber pop over multiple hops wirelessly as inexpensive as possible. And our cost reduction rests on 3 drivers. The first is we try to use the 57 to 71 gigahertz unlicensed band. There's plenty of spectrum out there, it's unlicensed. There's no upfront cost to obtaining permission to use that frequency. The second thing we try to do is we use phased arrays to do electronic beam steering. What that allows you to do is be pretty sloppy in your deployment. You do not need 2 dish antennas precisely pointing at each other anymore. Because of electronic beamforming, each node can find the next node or a backup node in case the first node is blocked for some reason. The third thing is we leverage as much as possible high volume consumer silicon that goes into mobile cell phones, so that we already from day 0 have a certain base volume that subsidizes a lot of the R&D. This is kind of very important, and it's also not very traditional in the infrastructure industry. Because we use consumer silicon, each wireless link is not 5 nines reliable. But you can do mesh networking to make sure that the network as a whole is robust.
Mm-hmm. Okay.
So these are the 3 drivers that.
Okay. We'll come back and touch on some of those challenges, but Joey.
I'll let Mike and Netin take care of the more technical aspects,
That's
but
fine.
I'll talk a little bit about what we're seeing. We're seeing a lot of RF interference in deployments. Basically, you're moving from tall macro sites, 100 feet and above, down to 30 to 40 foot structures. And the interference with all the clutter at that level is greater. So it can impact you when a tractor-trailer truck passes down through the right-of-way. So that's one of the areas that we've noticed of great concern. The other is just the deployments themselves in cost. We've done a lot of feasibility studies for clients because simply in the same example that Netton used a little bit ago, where our client is building out and just pulling in the power is a very expensive piece of it, let alone the backhaul. So they have a lot of surprises from the cost. So what we've started doing is doing feasibility studies and trying to point out some of those costs. So the surprise is not as great. So those are some of the things that we've been addressing as challenges.
So if you do, you know, I guess similar to what I talked about with the cost of the backhaul solution for a particular cell site, you know, if we have $3,000 for the equipment, $1,000 to install it, you know, I guess a $10,000 feasibility study for a site isn't gonna be too helpful.
No, and unfortunately, those sites drop out for us, which is a big disappointment. You know, the more sites we have to build, the better. But yes, and then we basically have to back up and decide which nodes or which sites are the most critical.
Okay. And Mike, you know, on the technical challenges, you know, in addition to just sort of the how-to challenges of getting the connection, what's sort of the requirement these days in terms of throughput? You know, nice that a small cell is small and has only X number of users, but sort of what's the throughput challenge that you're seeing ultimately these days?
Mostly it's translated into signal to noise ratio. We don't, when we're integrating a network for, usually on behalf of a carrier, they're not really coming to us and saying we have to have 600 kilobits per second or something like that. They're basically saying we have to have 12 dB of SINR variation between them. And that's what I would say, if there is one significant integration challenge from a technical perspective, it is, Joey kind of touched on it a little bit, it is ultimately creating the isolation between the two networks. We can talk about heterogeneous networks in the standpoint of they're supposed to work together. In reality, they're supposed to serve their customers and only their customers and then hand off to each other. So, you know, as a result, there is a significant amount of effort that takes place in isolating the small cell coverage footprint as well as the capacity it's served from the macro. And that's both on outdoor as well as on indoor. You know, when indoor venues are engineered nowadays, they're engineered around how much signal is coming in and how do I overcome it. Mm-hmm. So that by the time I'm inside, I don't even see the outside. It doesn't even register to my user.
Right. And Ron, so you might, you know, talk more about a fiber connection, you know, to that, but, you know, that has its own advantages and its own challenges as well.
Excuse me. That's right. All of the, I'd say almost all of the requests that we're getting from the wireless carriers are looking for a fiber connection for the small cell. You know, the front haul basically from the antenna or the back haul, you know, that they require. But traditionally they're using CPRI over dark fiber today, and you know, fiber connections can be, you know, expensive to build. I think the biggest issue that we're seeing though, and it's not so much a technical problem itself, but as the engineers in the wireless carriers are doing their RF analysis, doing their, you know, their engineering analysis to determine what sort of configuration they want, where they want to put the small cell and so forth, it seems like the technical solution that they're looking for the network is out of step with what they can get permitted and zoned. And you know, it kind of boils down to having a match between, you know, what you can get done in the jurisdiction versus what they're trying to do technically with the network. And we see a lot of cycles wasted where a design will come out and it'll be either a fiber design or an RF design. Both have issues when they're looking at a small cell CRAN type design with implementation, that the technical solution that the customer wants just isn't feasible to get it permitted and zoned. And I think that's the big problem.
So there, you know, you have three groups in the company. You've got the RF engineers who are like, okay, this is what we need for good coverage. You've got the connectivity engineers, hey, you know, the fiber runs right by over here. And then you've got the legal guys who have to, you know, so all three of those somehow have to get on the same page for all that to work.
That's right. As an example, you know, in a certain CRAN design that we did recently, the hub location was put on in a location that was very difficult to get fiber to. So the cost of bringing the connection was really the driver that broke that business case. You know, in other scenarios, you know, they want to put in a cabinet or a certain pole height, but that particular, you know, location that is selected for it doesn't allow that because of the zoning. And the zoning can change by street. You know, one street over can be different, you know, than the current street. And I think what we're seeing is it's not just price, it's time, it's the speed to deploy these things. And it's not always the time from when you have the contract and you're saying, go, let's deploy it, but it's actually the planning time that I think a lot of time is being spent because of not understanding what you can get done in a particular jurisdiction. Right. And I think all the jurisdictions are evaluating it and making their rules as we speak. So it's a difficult thing to really get ahead of.
So Nitin, you talked about, you know, utilizing utilizing very high frequencies, and so there are challenges around that in terms of, you know, how the propagation length and that has its own interference challenges, and also from a cost standpoint, does a radio at those frequencies, does that cost more than say something at, you know, 3 gigahertz or 5 gigahertz?
So in the semiconductor business, cost is a function of volume, and because we use derivatives of WiGig technology that is architected for consumer electronics, the costs are not very high. Also, we've architected solutions to be modular. The path loss at 60 gigahertz is very high, and you have, it's a hostile frequency because of oxygen absorption and all these other effects that reduce range. But one way to increase the range is just to increase the amount of power that your panel can output.
Right.
And what we do is we just increase the number of antennas. And this is very simple. And at 60 gigahertz, one benefit we have is the antennas are very, very small.
Mm-hmm. Right.
So for the form factor of an iPhone, you can have units that can communicate 300 meters line of sight with good margin at multi-gigabit per second.
Okay. You know, Joey, I'm gonna have you help Ron out here and talk about how Black and Veatch looks at that end-to-end process, as far as you know, we sort of have to bring site acquisition, planning, deployment, you know, all together.
Well, Black and Veatch's been pretty fortunate to have years of experience in the industry, not only telecom, but we've also worked with a lot of jurisdictions and public utilities from some of our other divisions, such as power and water and special projects. So there's a lot of relationships between those entities and Black and Veatch, which we leverage, and it helps us a lot in having those relationships. When small cells came along, we were basically setting up education sessions with the jurisdictions. They had questions. They wanted to understand the differences between small cells and macros. What is the advantage of one over the other? What size equipment? In that process, too, while we were educating and sharing drawings and specifications and everything that we could with them, they were also helping us through the process of the zoning and permitting and those types of activities. And it gave us an advantage to fast track over some of the others that were coming into the small cell industry. We also have our site acquisition specialists are out in the jurisdictions, so they know and understand most of those requirements. From time to time, they do change and they do learn a few new ones, but that gives us a big advantage. Our RF and our field engineering teams are working together to identify those RF nodes, putting together as much information up front that our site acquisition team is gathering from the jurisdictions and from the public utilities for equipment requirements and inspections. And then all of that information from each of the teams is put together with our project management and our construction management teams, so that what they're looking at when they're deploying, it's a unified effort. So a lot of our advantage is through the relationships that we have in helping us to overcome those jurisdictions. Now, there are some jurisdictions that even Black and Veatch has difficulty with. So.
Some are easier to deal with than others.
Yes,
If
definitely.
you guys are out there, you know who you are.
But it's nice when you can have a partnership with them.
Mike, one of the challenges, and I don't know, it's always it's still funny to be driving around in New England and see a cell tower disguised as a tree that's 40 feet higher than all the other trees, and well, that looks like a tree, I guess. But that is one of the challenges, and there are really a lot of innovative designs that are going on. Maybe you can talk a little bit about some of the practices in terms of making them aesthetically pleasing, and so that as you're going around town, it doesn't look like just a bunch of cell equipment up and down the street.
It's a little more challenging sometimes than others. In particular, whenever you go to a wood pole scenario, you do the best you can to make the wood pole look still like a wood pole, and there is certainly some shrouding that takes place. Some of it's required by the municipalities. In other cases, it's beneficial. Shrouding is beneficial not only for aesthetics, but also municipalities will have restrictions on how many attachments you can make. How many things can you put on the pole? And so if you put a shroud on there, you have one attachment, which is ultimately, there could be 16 or 18 things behind there, but the municipality doesn't see it, so therefore that's deemed one attachment. Ground furniture is another case where if you have the opportunity of something more aesthetically pleasing on the bottom, that's one. Obviously, a new one that came in is the whole smart pole type of solution. That has a little bit
that being like a light pole that looks very much like a light pole, but has a small cell inside it.
It does, but actually there's two versions. That's more of a stealth situation. You're just blending it in with the light poles. You blend it in with the existing environment. There's several cases of those. Those are more stealthy. The smart pole is something that it has both an aesthetic as well as a functionality benefit to it, where it does aesthetically blend in with the environment when maybe it looks like a light pole, but then it also may have screens on there, and it may have Wi-Fi connectivity for a smart city application. Case in point, there would be, you'd see the antenna, you'd see some sort of shroud on the top that would be the antenna for the cellular coverage, and then there would be behind a uniform structure within the pole, there would be a microwave solution. And then there's LCD displays that are information displays. It's you are here kind of interactive mapping situation. And where municipalities are just starting to see these come about, they're starting to not only see the aesthetics, but they're starting to see the applications for themselves. And that's where it really provides a significant benefit. If you can go into a municipality and not only are we not being disruptive, but we're actually offering you something that you can utilize for your own benefits, that's usually the win-win situation that you try for.
Right. Ron, let's come back to you looking at the fiber side and, the combination of Tower Cloud and CSL. That's a lot of fiber, but, there's just never seems to be fiber where you need it. So you talked before about dark fiber, and being able to use that to implement that. If we go to, say, a big city in China or a big city in Korea or Japan, we've got lots of that. Maybe not so much in the U.S. Or maybe, but talk about the availability of fiber and in most cities, I guess, and maybe tell us which ones are better than others. But then the challenge of finding fiber that's available. For a deployment, because if you have to pull fiber, to a particular small cell, that immediately gets pricey.
Right. So I think that, obviously a lot of fiber has been built to provide Ethernet backhaul to the macro towers in pretty much all the markets in the U.S. And there's a lot of fiber in a lot of markets, but as you said, it's not always where you need it. And the one thing about small cells that I think is very important is that when you're connecting them with fiber and to use CPRI over it, it's very, it requires a lot of fiber count. You have to dedicate a pair of fiber to each antenna pretty much. And so once your fiber run goes past that pole that you're dropping, those first 2 fibers at, you've stranded or wasted the rest of that infrastructure in the ring. And so what we've been doing is looking at our fiber designs to sort of change the way we can reuse fiber around the ring. The traditional fiber company doesn't like to cut up its fiber rings because it needs the diversity for reliability and so forth. But in a small cell scenario, you're using it on a point-to-point dark fiber connection, and it's not feasible to do that sort of a connection. So what we've tried to do is put in more frequent handhole access so that we don't have to really build along our fiber route to get to the handhole where we're going to splice it in, that we can actually get it closer to the location of the antenna. We're using multiple conduits so that we can dedicate conduits to the small cell network and sort of use it as an access on-ramp, if you will, to the larger backbone. But at the end of the day, I think that to get the fiber out to the locations that the small cells are required is going to take some new greenfield build. And it's that combination of being able to blend that capital cost in with the other uses of the fiber network versus having it just dedicated to the small cell that I'm going to really think change the price point for how you get the backhaul or the front haul to the antenna.
Okay. Nitin, you had touched on Broadcom system-on-chip capability and the capability to drive the cost down. How does that get applied? As you look, specific, but either in terms of from a technology standpoint or from a product standpoint, for what you guys have produced to target, the 4G small cell market specifically.
So we try to leverage, Broadcom is one of the world's leading companies for Wi-Fi. And what we try to do is leverage as much of our technology from Wi-Fi into these new wireless standards. This not only includes the IP or the building blocks of the chips themselves, but also things like test infrastructure, software, so that our partner companies don't have too much of a steep learning curve because they're familiar with the products that we ship today. So we try to keep them as close to what they're familiar with. So that's one piece. The other piece is this market is so new that we cannot forecast how it will settle. I cannot tell you today what is the range that the market needs to connect a small cell site to the closest fiber over wireless. And that's why we've tried to make our system as flexible as possible so that as people learn and discover what is the optimal configuration, it does not demand us to tape out and design new chips for each iteration.
And where is the, help me to understand, where is the flexibility on the RF side or in the baseband processing side?
The flexibility is on the RF side.
Mm-hmm.
So you can arbitrarily increase the number of antennas that our RF module would have to support.
Okay.
And the baseband, most of the logic, the timing sensitive logic in the baseband is really software. So we can change that with a firmware upgrade. But the real flexibility comes in the way we've architected the RF front end.
And so I described, I described my particular bent around the business case when I have my little box there as cost for the broadband wireless connection to each cell site. Am I going to be happy or am I going to be unhappy?
Well, we were very optimistic about it, and the reason is because we used phased arrays. This means that we're not broadcasting energy in every direction. We focus a narrow beam of energy towards the receiver. This allows us to use the spectrum more wisely. We can
Cheaper
densify.
power amps.
Exactly.
Mm-hmm, mm-hmm. So under so I got your target is $4,000. If it's above, I'm going to cry. If it's below, I'll be okay. Am I going to be okay?
You'll be very
okay.
You'll be
Good.
fine.
Okay. Again, Joey. So we focused a lot on small cells, outdoor. And then there are also challenges for deploying indoor. And maybe you can talk about the difference, people are deploying small cells, maybe for a particular company, for a particular operator, indoors. Maybe talk about the challenges between an indoor deployment for an outdoor deployment. I'm guessing, but I imagine B&B has been involved in both.
Yes,
Okay.
that's correct. For the indoor DAS scenario, it's pretty basic. You still have the same RF challenges as you would for, I would say, small cells in a different environment and interference. But when you look at a DAS project, you look at it as a whole, and that project, depending on the complexity and how large, can take anywhere from a couple of weeks to 6 months, maybe a year. The vast difference for us on the deployment side of DAS versus a small cell is the small cell, the acceleration rate and the volume needed for that deployment is huge. For a company such as Black & Veatch and others that do the deployments, it would be comparison to macro or DAS, where you would have to just imagine in the world that if you had to prepare your food every day, and then tomorrow and every day thereafter you have to do the same. And that acceleration rate is so great, which drives a great demand for a very robust logistics system. Whereas with DAS or ODAS, that acceleration rate isn't something that is adding to the complexity. There's other technical issues. There are issues involving whether you're working at night with crews or restricted security, so forth and so on. So does that cover it pretty much? Okay.
Sure. All your answers are good. There are no wrong answers here.
Okay.
Mike, so one of the things that ExteNet is involved in building neutral hosts, which is often a different model where that's a shared infrastructure. And so that's something maybe more well known. We'll come back and we'll touch on that. But how have you seen that model get deployed into the outdoor market, where you act as you use the word neutral host? I think you were describing more than just the indoor networks that you're involved in. How would you see that? What's your interpretation of the neutral host model is getting implemented in the outdoor market?
The first thing I'd say is that neutrality has a different meaning than when it did 3 or 4 years ago. Neutrality back in the true just DAS type of deployments, the neutrality was based from, you had a very fine demarcation between the carrier-owned equipment and your equipment. It was very rigid. And today, that neutrality is, those demarcations, there are more of them and they're more complex. The carrier will take their equipment to a point where then it joins with our fiber, and then it goes back to their equipment and goes up to our antenna. So you start seeing these demarcation lines and neutrality blurred. And with any kind of small cell deployment where you've got, really in this example, it's a baseband unit and a remote radio head combination, where those pieces are owned by the carrier and yet the infrastructure is owned by us as the neutral host, that changes how both the business structure as well as the technical structure and the operational structure and what needs to be supported. It is different than what it was when it was just a DAS deployment situation. And so as a result, and that's both indoor and outdoor, when you start talking about a neutral host scenario, the neutrality comes in really the attachment as well as the use of the fiber in many instances for any kind of small cell deployment, indoor or out.
Right. So when you're talking about an indoor deployment, it's a much more contained system. It's a lot easier to sort of block out and understand, here's what we're going to do in this building. Here's the people who are in this building usually. here's the equipment, here's our equipment. It does seem, what are some, you touched on some of it. I'll start at one end of the chain. We need the antenna, and then the connection to the radio, and then the baseband, and then we need power to all that. We need a backhaul out the end of it. It's eventually going to the core equipment. Maybe in this broader definition of neutral host, the neutral host could think about supplying any one of those or any combination of those.
Very true. Yeah, there's as it stands right now. If you talk about indoor neutrality within a venue space, it could be the antenna, it could be the antenna and the coax, it could be the antenna and the coax and the fiber, which is typically the case. They may own the small cell. We may own the small cell. If it's something that's more of a whether it be a common band or whether it be a band that's available to everybody, there may be some opportunity. That's more on that looks more like Wi-Fi than it does really small cell, but there's that possibility that exists. And the one thing if you want to call it difference, technically on the outdoor side you have the municipality. The difference with the venue is you technically have two customers. You've got the carrier customer who is interested in serving their subscribers within the building, and then you have the building itself. The venue itself, it becomes a customer, both from the standpoint of they may or may not have a financial aspect to it, but they certainly have an aesthetic one. I would challenge anybody to look around the room and see if they could find the antenna that's in this room. And one of the reasons why you may have a difficulty with that is because the venue itself is saying it has to be it cannot be seen, it has to be in this scenario, which can bring its own challenges. Suddenly now you are catering to two different masters, one that wants ubiquitous coverage or ubiquitous capacity delivery, and one that says, I don't want to see anything, I don't care what sacrifices you have to make on that regard.
And in the case where there's more than one operator, there might be more than one antenna, which is that's really horrible. That you want to avoid.
Very true. Small cell deployments are becoming much more popular within venues, and the venues have to be resigned to the fact that they may see multiple sets of equipment.
Or they'll say hell no, which is
or they'll say hell no.
which for me, I think that may be the right part. Ron, you want to chime in here?
I just want to jump in on this neutral host model. I think as you talked about, the neutral host model is sort of changing, and I think when we talk to the carriers about different projects, they're reluctant to get involved in a neutral host situation unless they absolutely have to, because they're traditionally trying to do something different than their competition. They don't want to have the same coverage, or they don't want to enable their competitor to come on their backs and join that same system. In some cases they have to if there's a building rights or contractual rights where somebody has signed the agreement and they're going to be the operator for all the carriers in that venue. But I think what's really important is that we've got to be able to get to a shared infrastructure model where the cost is shared. And at least on the fiber-connected systems, even if they're requiring different locations for the antennas, or they're going to go on a different pole for some reason, if it's just the pole right down the street or next to the other one, it can still share a lot of the cost of that fiber system that's serving multiple carriers, even though they're really individually negotiated transactions.
All right, Ron. Now you've done it. You hit about 5 of my hot buttons in one answer. So okay. Now we're going off the rails here, but we're going to get serious. Number one, so everybody knows where I'm coming from. I think you said shared infrastructure. Okay, I think that shared infrastructure is over the next 4 or 5 years becomes one of the most important areas in all of our industry. And I think that we touched on it earlier. The operators just cannot continue ad infinitum because they don't have to keep paying the same amount every year to keep up with capacity demands. The payments that they have to make goes up like exponentially each year, and so it becomes more and more difficult. So the need for shared infrastructure, that was one hot button, probably the biggest hot button. The other, and Mike, you touched on it. So let me ask you. So between, and you also have the tenants in some cases. So between all those constituencies, I'll give you just free rein. Who should pay who? You got you guys.
Yes.
You guys in the middle.
Everybody should pay.
Everybody should pay. So you're in the middle. You got tenants. You got building owners, venue owners, and you've got M&Os. Who pays who?
There's obviously differences. We were talking about this before we came in. There's
Sure.
obviously differences now where you can consider wireless to be much more of a utility than it is. It's certainly it's gone beyond a luxury. It is an expectation. And think about the scenario like Wi-Fi. Think about hotel Wi-Fi as an example. About 7 years ago, 6 years ago, maybe even as soon as recent as 4 years ago, you walked into a hotel, you paid as a person renting a room, you paid $20 to $30 a day for their Wi-Fi use. Probably wasn't very good either. It was probably, barely connected. Now the difference is that you won't go to a hotel that doesn't have it. And by the way, you'd be surprised if you had to pay for it. And so that's an example of an economic shift where now the venues are taking that responsibility because they realize in order for us to maintain competitiveness, in order for us to not lose people going to another hotel in this example, we have to provide that payment for that infrastructure. And so to answer the question more specifically, there is certainly a piece where the venue should have to feel the right to pay because they are looking at it from this is a utility, it's no different than water, it's no different than electricity. We have to provide this as an expectation, not as a luxury.
I'll tell you the difference. I'm not sending $60 a month to the Wi-Fi company to provide me Wi-Fi. I'm sending them $60 a month to provide me wireless connectivity. And the way that I see, the whether it's in building, or exterior, and I want to come back to your question about how does that shared infrastructure model proliferate out into the network, but really, if ExteNet builds an in-building network in the Sears Tower or whatever, you're building an extension of their network. Not only, and you're also deburdening their macro network from having to provide, requests in there. And the people who, if I work on the 80th floor of the Sears Tower, shoot, it's not the Sears Tower anymore.
Willis Tower.
Willis
But if you're
Tower.
from Chicago, it's the Sears Tower still.
Okay, I'm good.
And it's always Comiskey Park, and it's always Marshall Fields.
Yeah, it's still Comiskey Park.
Right.
Okay. So, if I'm an AT&T user and I go up to my office, I'm like, okay, people are calling me on my phone on my AT&T service. That's what I expect. And so, because, you have to have coverage, you can't have all of them come in. Neutral host has to, a multi-operator network, I'll leave it at that, has to be the norm, I think, more and more going forward. And, the operator should, the operator should make a fair contribution,
At minimum, what the operator can't possibly or can't relieve themselves of is the responsibility of the rent of the space. The venues,
Correct.
if the venues are allocating some space for their equipment,
Right.
it's very challenging for a venue to say, yeah, I'll give that up for free, especially because the venue's goal is to rent space for money. And so that's one of the things that they can't.
So I think that, my unbiased, opinion is that, you guys get the right to, have the wireless, you negotiate for the rights for wireless in the building, you pay a rental fee and an access fee, for that right, and your right is then to turn around and make a contract with the M&Os, which is, there are multiple models I know within ExteNet. I mean, that's certainly one of them. So let's go back to shared infrastructure, and we'll come back outdoors. But what does that mean to to a deployment or for the cost? First, Nitin, for the solution that you want to propose, if it were if it were either an outdoor DAS or a multi-operator small cell solution, would you suggest, would you change the solution, or how do you see that as first step from the technical solution side?
So in our case, what we're trying to do is replace the fiber that comes to the small cell site, right? We want to make wireless fiber on the back end. How the user accesses that network, I'm completely agnostic to. Could be 5G, could be Wi-Fi. As Broadcom, we like Wi-Fi. We have a strong feeling that actually 80% of all wireless data goes over Wi-Fi for a very good reason.
Sure.
And we don't see that changing for the reasons that you outlined. You don't have to pay $60 a month to Broadcom for Wi-Fi. And that's very convenient.
So Joey, it's Ron's fault because he poked me with his sharp stick over here. But yeah, I mean, how this idea of a shared infrastructure, and again, in a venue, it's much easier because it's much more contained. But either what situations or how more and more as we go to the future, do you see a shared infrastructure model, taking hold in the out and about market? Because for my belief, I think that you'll see the days of where can you hear me now? I mean, that's not a marketing thing anymore. If there's a 2% difference between Verizon's network and Sprint's network, or let me say it another way, if there's not a big enough difference between the networks that that users can tell the difference, does it now become a marketing issue? And maybe we're not quite there, but maybe it's getting close to being there. And so maybe the infrastructure of an operator and the services part of what they offer of an operator become more decoupled. But how do you sort of see that model, and how do you see that maybe shared infrastructure can start to come to the outdoor network? I talked a long time, so you could.
You did.
have a
I hope
while
I didn't
to-
lose all of that
to-
in there.
to come up with your answer.
Well, from our perspective, we do see more of the shared infrastructure. And as you're talking about bringing it to the outdoors, I see in the role that we're playing at Black and Veatch, we're seeing a lot of the smart city scenarios where we're mixing the cities and different venues with the carriers, with a lot of demands from different entities within the city. So it gets very complex. So that shared entity is going to be more complex as we go, but it's certainly going to share to the need for the capacity and the coverage as a city overall, which will benefit more and more as we go.
Okay. And Ron, okay, so you share, he's sticking me again. So you share this sort of thought about shared. How do you see that this can start to come in? And a lot of times, and when we work with our clients, often we go and we sit with operators, and usually the first word that we hear is the C word. We have to control our network, and then once maybe shown, economic benefit, and Mike, that may be part of your experience. Once shown economic benefit, they kind of get over it, or the finance guys tells the engineering guys to shut up, so or something like that. So, but anyway, Ron, you started this, so it will give you a better shot at it.
Well, I think that the economics are going to drive it to a shared infrastructure, especially as long as fiber is involved as the main component of it. I think that's a key thing to share. But I also think just the other aspects of deploying it and standardizing things so that you can do things consistently. I don't know if that's really shared, but it brings the cost down and enhances the speed. And I go to one of the comments that Mike made a second ago about how hotels, now it's a necessity to provide this sort of a wireless communication. We see a completely different approach from different cities and jurisdictions. Some see it as a revenue opportunity, and they want to charge for the right-of-way or something to install small cells. Other cities look at it like, if I don't have advanced wireless communications in my city, I'm not going to be able to attract businesses or retain businesses here. And so I think that the cities and just like the venues, the cities and the jurisdictions that have more leadership in realizing this is important to their communities and how they can get benefit out of it, they're going to set that standard. And they're not going to want the streets dug up twice or 3-4 times to deploy small cells for everyone. They're really not going to want everyone to be on their own pole. They're going to want it to be restricted so that it's more stealth use and things like that. So I think that it's going to be those cities that are out in front of it, that are embracing this change rather than trying to resist it. And that's why, to Joey's point, I think getting out to the jurisdictions up in advance and talking about what you want to do and not surprising them, will help to standardize things and help to get them to require through zoning and permitting more of a shared infrastructure model.
I mean, that's, okay, so we're gonna open it up, let's see if there are questions from the floor. And, whether it's around, deploying small cells connectivity, shared infrastructure, if anybody else wants to chime in here. Yeah, okay, we got a question right there. Do we have a mic here? Let me see if we got a mic. Great, I'll fill, you want to fill some more dead air on this?
I'll add one thing to Ron's comment. I have a great story. This is years back, but I was at a very restrictive municipality that were spending an inordinate amount of time, energy, and money to keep cell towers out. And there was a significant amount of remonstration saying, no, we don't want this. It was a tree application. No, we don't want this. We don't want this. We don't want this. Then 2 years later, after the tree finally got approved, 1 year later, I had to go back for another one. And there was a whole group of remonstrators saying, we got to have this, we got to have this, we got to have this.
Great. What do we got? Go ahead, shout it out.
Ron had mentioned on your CRAM example where you had an RF team, an activity team, and a planning team, but the problem was the municipality. If you had an one, what was the solve the problem?
Yeah, so I'll just repeat. You can tell me. So we talked about that there was like the RF team, the fiber team, and then the guys who had to deal with the regulators. I think that was your issue, and and the.
Well, I think the key is to improve the amount of information that the RF planners have when they're designing the networks up front. And that comes from the local market knowledge like Joey was talking about in terms of understanding what can get done in a certain city and how to go about doing it, rather than finding out while you're in the middle of the project after you've already got the design in place and you got to change, you got to basically start over and reconsider what you're doing with your design. So I think it's really the advanced knowledge of knowing what a city will allow or what can be done in a particular jurisdiction that's got to be your starting point when you design your solution.
Great. Any other questions from the audience? We have time for like one or two more questions. Anything? Oh, yeah. Oh, there we go.
Just like to solicit some constructive feedback on what you think about CBRS, the Alliance, and shared spectrum push, and maybe that's a way where you can build wireless.
Sure. So two challenges, and Mike, just wave at me if I'm going off the rails here. But two ways. If you want to support all the operators, there are two things that you can do. Number one is support all the frequencies of all the operators, and maybe they each want a 3 and a 4G frequency supported, or find one neutral frequency that everybody can be happy about. And so then when you look at things like multi-fire, you look at things like CBRS. Very important to, that is a potential alternative. Of course, one of the challenges is that those frequencies and have to be supported on each of these guys to make them effective. Is that helpful in an in-building solution? Sure. Is it potentially a way that you could deploy a shared infrastructure where I'm going to put 3 CBRS, small cells in the middle of Times Square, and when the other operators get kind of, overblown and hit their overflow button, their subscribers can then sign on to those. So I mean, that's one way that those could potentially be. In fact, stay. I think it's tomorrow. There's actually that's a great advertising. There's actually a session I think that we have tomorrow afternoon that covers exactly that. But I'll give the panel the use of a neutral spectrum. You like that one or?
So I personally am very bullish on CBRS, especially in deployment environments that call out for non-line of sight. So indoors, yes, CBRS could be a very big advance. Coupled with technological innovations like massive MIMO, it could be something. In line of sight, I think millimeter wave still has some advantages. So I think they would complement each other very well. The days where the telecom industry operated on a cost plus model may be behind us. We need to find ways to cut the cost because I don't think we can pass on the cost as price increases to the end customers anymore.
And Mike, I mean, ExteNet, interested in those, looking at those?
Very,
think about
yeah,
those?
yeah. Google has a lot of money, but they don't necessarily want to lose it. And so when if you see a big multicolored rabbit around, you kind of get the idea that it's probably a pretty big deal. And even to the point of the mobile phones, I mean, they'll have a significant amount of influence in making sure that those are compatible. Carriers are looking at it, different providers are looking at it, infrastructure vendors are looking at it, companies, neutral host companies like ourselves, we're looking at it. It is definitely an expected solution going forward.
Great. All right, super. I want to thank everybody, and I want to thank our panelists. Thank you very much, guys.